Welcome to The Explainer. Today, we're tearing down the engine of a highly engineered 16-part blueprint specifically designed to completely conquer university exams. We're looking at an absolute masterclass in academic strategy, and we're using the syllabus from AKTU, which, if you know it, is a notoriously rigorous state technical university, as our testing ground. This isn't just a basic list of study tips. It's a complete structural deconstruction of how to learn, retain, and perform at the highest possible level.
Okay, let's jump right in with the golden rule that basically sets the tone for this entire system. Do not blindly assume an old syllabus. This blueprint treats exam prep like high-stakes architecture, meaning accuracy is your foundation. Think about it. If you start building your study plan on outdated topics or irrelevant previous year questions, the whole structure just collapses. This guide demands hard evidence before you take any action at all.
To pull this off, the blueprint is broken down into 4 core phases: groundwork and study strategy, core content and master lists, application practice and testing, and finally, the final revision sprint.
Phase 1. Groundwork and study strategy. Because an architect never builds without surveying the land first.
Look, before a single note is written, this blueprint demands what it calls a research and syllabus verification report. It's an absolute requirement to verify the latest syllabus, the trends in PYQs or previous year questions, and official university resources. You don't just guess what's going to be on the test, right? You cross-reference official portals, analyze those frequently repeated concepts, and find the actual evidence of unit-wise mark distributions.
So what do you do with all that research? You categorize. Every single topic is funneled into a really strict 4-tier priority system based purely on reliable evidence, not just a gut feeling. You've got your very high priority must-do topics, followed by high priority, then important, and finally normal for that extra practice. It's literally about putting your energy exactly where it's going to yield the absolute most marks.
All right, priorities are set. Now, you need a timeline. The blueprint maps out 3 very distinct, realistic daily targets: a 7-day revision sprint, a 15-day preparation plan, and a comprehensive 30-day complete strategy. It tells you exactly what to study first, what needs to be purely memorized, and what requires deep conceptual understanding, all based on how many days you actually have left until the exam.
Moving right along to Phase 2, core content and master lists. This is really the engine of the blueprint, where raw syllabus topics transform into highly structured study materials. This is where the magic happens. Every single chapter gets a standardized architecture. You always start with prerequisite concepts, then move to core definitions, isolate your formulas into specific boxes, and then tackle the derivations and numericals. And crucially, it's designed to be written in super accessible language, like a mix of Hindi and English or Hinglish, to ensure concept clarity. It's meant to read like a senior student explaining it to a freshman over coffee.
Now, what about those terrifying, massive math derivations? Well, you don't just memorize them. You follow a very specific formula. First, you state the objective. Then, you explain the starting principle, list out your assumptions, and derive it step by step without skipping a single intermediate math step. Finally, you highlight that end result. It takes this scary wall of math and turns it into a logical, easy-to-follow story.
Alongside the chapter notes, the blueprint has you build a standalone formula handbook. But this isn't just a basic list, it's a full-on database. Every single formula is isolated unit-wise, detailing its symbols, its SI units, and exactly when to actually apply it. And the ultimate goal here, to eventually condense everything down into a single one-page ultimate revision sheet for exam day.
Phase 3. Application practice and testing. Because let's be honest, having pristine notes means absolutely nothing if you freeze up under pressure.
Testing in this system is a tiered progression. You don't just dive headfirst into past papers. You start with basic foundation tests, then move up to moderate concept builders, and then you hit the rigorous actual university standard. After that, you push into difficult territory for advanced mastery, and only then, at the very end, do you attempt a full, complete simulation. Plus, every test requires a complete answer key and a really strict self-evaluation system.
The numerical practice gets the exact same VIP treatment with a dedicated numerical master book. It walks you through a systematic escalation, a basic example, a moderate one, a difficult one, an exam style problem, and finally a verified PYQ. Along the way, it specifically trains you on unit conversion, scientific notation, and how to pick the correct formula without panicking.
Okay, here is a massive pitfall where students lose easy points: presentation. The blueprint provides exact guidelines for answer writing. It dictates exactly how much detail you need for a 2-mark versus a 10-mark question. It trains you on exactly where to place your diagrams, how to underline key points, and how to structure your equations. It's all about making it ridiculously easy for the examiner to give you maximum marks.
And finally, Phase 4, the final revision sprint. These are your emergency protocols, designed to lock in that knowledge right before you walk into the exam hall.
There is a huge difference in how you should spend those final hours. Your last 24 hours protocol focuses on the most important formulas, definitions, and top conceptual questions. Think of it as a broad survival guide. But your last 1-hour protocol, that is laser sharp. You strip away all the long explanations. You are strictly looking at the formula, the core concept, a derivation keyword, a diagram, and the most critical point. Nothing else gets your attention.
To make sure you don't trip right at the finish line, the blueprint includes an amazing preemptive strike, a checklist of the 50 common mistakes students make. We're talking unforced errors in formula selection, messing up units or negative signs, totally blowing your time management, or just sloppy presentation. By reading these mistakes before you make them, you're basically bulletproofing your exam technique.
And how do you keep track of all this? A personal study dashboard. It's a printable, unit-by-unit checklist. Did you do the concepts? Check. Formulas? Check. Derivations, numericals, PYQs, mock tests? Check, check, check. It gives you this incredibly clear, visual confirmation of your mastery. Your exam anxiety just kind of melts away because you know exactly what you've already conquered. The ultimate goal of this entire massive system is extreme distillation. As exam day gets closer, your 10-page quick revision notes condense into a 3-page supersheet, which finally condenses into that 1-page ultimate cheat sheet. You are squeezing absolute maximum exam value into a single, highly potent page of pure information.
So we've just unpacked a highly organized, completely evidence-based engine for academic success. It relies on tiered practice, structured rules, and that extreme distillation at the end. The methodology works wonders for engineering physics, for sure, but the framework itself, it's completely universal. So I've got to ask, what complex, daunting subject are you going to build a mastery guide for next?